Okay, we have a triangle here, ABC, and we are going to find a point that is equidistant from all three vertices of the triangle. This point, by the way, is called the circumcenter, and it's the center of a circle that circumscribes the triangle. So if you drew a circle that passed through all three vertices of the triangle, then the center of that circle would be called the circumcenter, and that's what we're going to find. Okay? And the way we're going to find it is we're going to first find the perpendicular bisector of AB, and that'll contain all the points that are the same distance from A as they are from B. And one of those points in particular is going to be also the same distance to B. So we have to find next the set of all points that are equidistant from B and C. And once we find that, so we'll have a perpendicular bisector that goes through here, perpendicular bisector that goes through here, and the place where they intersect will be a point that is the same distance from B as it is from C, and the same distance from A as it is from C, and so it'll be the same distance from all 3 points. So first we need to find the midpoint of AC, so the perpendicular bisector will pass through that point. And if you look here, we have 4, 12, 4 plus 12 over 2, and 1 to 5, 1 plus 5 over 2. So that gives us, see, 4 and 12 is 16 over 2 is 8, and 1 plus 5 is 6 over 2, that is 3. So 4, 5, 6, 7, 8, and up 3, right there. Next, the slope of AC, so that's 5 minus 1 over 12 minus 4, which is, let's see, 5 minus 1 is 4 over 8, which is 1 over 2. So the slope of our perpendicular bisector will be the negative reciprocal of that, or negative 2 over 1, or negative 2. So now we're ready to write our equation. It's y equals mx minus h plus k, where m is the slope of the line, and hk is just some point that's on the line. In this particular case, it's going to be the midpoint of that segment. So we have y equals negative 2, x minus 8. Remember, if 8 were a negative 8, by the way, then we'd write x plus 8, x minus a negative 8. But it's positive, so it's x minus 8. Plus 3. Now we'll do a little simplifying here. We get negative 2x, negative 2 times negative 8 is positive 16, plus 3 is plus 19. And I am going to go ahead and sketch that line in here. You get a ruler. Okay. Let's see. So that line, let me kind of sketch a few points here. Alrighty. And I hope, try and ruler over so it works a little better. Okay. And I hope that I haven't, well, I may have. If my circumcenter is down here someplace where it, because it very well may be, I'm going to have a problem. I drew over top of it. Okay. Next, we're going to find the perpendicular bisector of this segment. It's going to be a little bit more difficult. So the midpoint is, let's see, 5 and 12, 5 plus 12 over 2, 4 and 5, 4 plus 5 over 2, and that's going to turn out to be, let's see, 5, 12, 17 over 2.
Hi, Kenny. Could you go to room 2106, please, when you have the opportunity?
I've got
Thank you.
9 over 2. So you can already see how this is going to be a little bit more problem because we're dealing with some fractions. 17 over 2, by the way, is 8.5. 9 over 2 is 4.5. So that is 4, 5, 6, 7, 8, 1, 2, 3, 4, right here. Okay. Next, the slope of BC is, let's see, it's 5 minus 4 over 12 minus 5. So that's going to be, let's see, 1 over 7. So slope of our perpendicular bisector will be negative 7. Okay, so let's see. That's going to be 1, 2, 3, 4, 5, 6, 7 over 1. 1, 2, 3, 4, 5, 6. Ooh, we're off the charts there. Too close to the top. So our line is going to go. Oof. This is kind of a delicate operation here. All right. So it looks like our point of intersection is going to be in the middle of that square. I just want to find out roughly where it's going to be so that we actually calculate it. See if it makes sense or not. All right, so our equation, y equals m, x minus h plus k, slope, and hk is the point. Slope is -7, x minus, so we got our 17 halves plus 9 halves. Y equals -7x, and here I want to get a calculator to do the dirty work for me here. Let's see, this is going to be 7 times 17 ABC2 is 59 half. Let's see, and that'll be positive plus 9 ABC2, 64 plus 64. That turned out to be kind of not so bad a number. Okay, so that's our equation there. Now we're going to find that point of intersection. So we take the two x parts of the equation and we just put them equal to each other and solve for x. And that'll give us the x coordinate of our point of intersection. Then we'll take that x coordinate, plug it into one of the equations, and find our y coordinate. So let's see. Find the intersection of the two. So we have -2x plus 19 equals -7x plus 64. See, we'll add 7x to each side, and that's going to give us 5x. Subtract 19, 64, 54, 44, 45. Oh, look at this. This is going to turn out to be kind of a nice number. X equals 9. 4, 5, 6, 7, 8, 9. My sketch might be off. You know that? We need to take a closer look at that. And let's see. Then we'll go back and plug 9 in. I have to be 4, 5, 6, 7, 8. I have to be out here. I want to pause this for a second. Something doesn't look right. Nope, we're good. Just my sketch is terrible. Okay. So let's see. So now we're going to plug 9 into one of these equations. Doesn't matter which one. So I'll pick this one over here.
Mr. Ashley, can you please contact the main office? Mr. Ashley, can you please contact the main office?
9 plus 19. That's -18 plus 19, which gives us 1. So our point is x equals 9, y equals 1, which is actually right here. And we'll check. Drop here. That is 3, 4, which makes that 5. 1, 2, 3, 4, 5. That's 5 units to A and 5 units to C. And from here, it's 1, 2, 3, 1, 2, 3, 4. So there's that 3, 4, 5 triangle again. 5 units to B. All right, so this point right here is equidistant from all 3 corners. And my diagram is just really terrible. I don't know. It's hard to draw that sketch right there. So anyways, the process here, just to review, is we had to find the perpendicular bisector of AC and the perpendicular bisector of BC. And then, so we write those two equations. First, we have to find the midpoint of each, and then we have to find the slope of each. The slopes of the perpendicular bisectors are those negative reciprocals. So you flip the fraction upside down, change the sign. After we write the two equations, then we set them. We write the two equations, by the way, using that point slope form. We know the slope. We know what point it goes through. Just fill it out, do a little simplifying to get the equation. We take the two equations and sort of put them equal to each other and solve to find an x value of the point of intersection, and then plug that x value back into one of the equations to find a y value for the point of intersection. And then we just went back and double checked to find if that point of intersection was in fact the same distance from A, B, and C, and it is. It's 5 units from each. A couple things to point out. One is we could, of course, gone back and plugged 9 into the other equation, and we should also get 1. That'd be a good double check to make sure you've done it correctly. And also, we could have gone and done the perpendicular bisector of AB as well, and we should have ended up with the same point, because this perpendicular bisector is all the points that are the same distance from A as they are from B. Well, that should include this point right here, because it is the same distance from A as it is from B. Right? So we could have done this perpendicular bisector instead of this one, or we could have done all three as a double check. And there we go. That diagram. Why did that diagram turn out so badly? Boy. Well,